In this explainer, we will visualize displacement, velocity, and acceleration. Starting with our car at home, distance 0, let's move the time slider and observe its journey. Notice the car's movement. Let's decode, understand what is that red curve. This is called the position curve. It follows the formula S is equal to initial distance plus velocity times t plus half of acceleration time squared. Since we have t squared, this red curve looks like a parabola, a quadratic. This shows how far the car has traveled from its starting position. U is our initial velocity, A is acceleration, and S0 is the starting position. Okay then, so we will cover all these in the next slide. Let's go. Here is a slider called S0. S0 represents the initial position of the car or its displacement from the origin, that is home here. By adjusting S0, observe how the position curve on the graph changes. As we raise the value of S0, the position curve moves up vertically. Ask why. It is just the car's starting point in relation to home. You can also reset the time and move the car to see this change in motion. The key takeaway from this activity is to understand how the initial position, time, and motion are interconnected and visualized on a graph. Let's take a quick look at how a car starts moving. The blue dot in the graph you see marks the car's speed. When you begin watching, that's the initial velocity marked as u0. Now, the way this line tilts represents acceleration. If it is constant, the line keeps the same angle. Here, looks like the line keeps the same angle. More on that in the next slides. For now, just remember, the starting spot, the blue dot, is our initial velocity. Change the value of the initial velocity in the slider and observe where the dot moves to. That's the initial velocity. And the line tilt tells us if we are speeding up or slowing down. Keep in mind, and we will get into the details very soon. Acceleration is the rate at which the car's velocity changes. That is the rate at which the car's velocity changes. In our interactive, you can adjust the initial velocity and watch the position of the blue dot change. This dot represents how fast the car is moving when we start watching, right? Now, if you increase the acceleration, the blue line or the velocity line gets steeper, indicating the car is speeding up faster. Conversely, a negative acceleration value means the car is slowing down. By moving the time slider, you can see these changes in the motion of the car. This is a useful way to visualize how acceleration affects movement or displacement. Let's wrap up what we have learned. The S0 represents where our journey begins, the initial position of the car. The U0 is our starting speed. And as we move forward in time, the car's velocity U evolves based on its initial speed and the car's acceleration. Let's repeat. The car's velocity U evolves based on its initial speed and the car's acceleration. This is very important. The blue line reflects this, angling steeper with more acceleration. Our position curve, the red curve, described by the equation S is equal to S0 plus U times T plus half A times T square, combines these elements. Where we started, how fast we are going, and how quickly we are speeding up or slowing down into one graphic. Remember, a steady angle means constant acceleration, and that curve shows us our displacement over time. The position curve, which is in red color. Thank you.